Another situation that is similar to finding the area between two curves is calculating the area in a bounded region. When I say a bounded region, I am simply referring to a region which is finite, where the perimeter of that region or the boundaries of the region are the indicated curves. We are looking for a finite region where the perimeter is the indicated curves. Our previous examples could have been rephrased to areas bounded by. For instance, in example 1, we said the area between y equals x, y equals 6 minus x squared on the interval from 0 to 2. If instead we would have rephrased that to say the area bounded by y equals x, y equals 6 minus x squared, x equals 0, and x equals 2, it would have been the exact same problem. Let's go ahead and graph that just so I'm clear. When I graph the four curves, let me actually change the color on that one. When I graph the four curves, you can see that they cross all over. And you say, well, there's actually a number of different finite regions that this thing bounds. So, but we are looking for the region that's bounded by all four. In other words, the region that touches all four of them. Now, in order to touch this green, well, let's look at this first. If I am in here where my cursor is, the region touches the red, the blue, and the purple. So that can't be the region we're looking for. Even though it's a bounded region, it doesn't touch all four sides. If I were down here, I may say, well, look at this. At this point, all three touch. So this region touches these three curves there, and it also touches the blue curve. So this region down here touches all four curves. However, it's not bounded. It goes down forever and ever and ever, and so that region is infinite. The only finite region that is bounded and touches all four curves is the one traced out here. Now, it only touches the green curve at a single value of 2, but it still is touching at that point. So here's our region that we're looking for. And that's the same region we had when we were dealing with example 1. Let me shade that region now. X less y less than 6 minus x squared from x equals 0 to x equals 2. So that's the same region we had in example 1. I'm not going to recalculate what the area of that region is. I just wanted you to visually see what's happening when I say the area bounded by curve A, B, C, and D. Not every region is going to be bounded by 4 curves. Some regions may be bounded by 3 curves, and some regions can even be bounded by 2 curves. In example 4, we say find the area of the bounded region created by the following 2 curves, f of x equals 9 minus x squared. G of x equals x plus 3. We want to find the area bounded by those two. Let's go ahead and graph these so that we can see what's happening. I've graphed these on Desmos so you can see it. In this case, we're looking for the bounded region. If I'm where my cursor is, this is obviously an infinite region on the outside. This is an infinite region. Don't be fooled by this x-axis. This x-axis is not a line of bounding. So when you're here, this region covers all there. It's unbounded. So the only region that is bounded that these two curves create is the one in here. Notice that in this bounded region, the f of x is on top. Here I had written f of x equals 9 minus x squared. And the g of x is underneath. So I need to, when I'm finding an area, I need to figure out which curve's on top. Now I know the f of x is on top in this situation. Which curve's on bottom? Now I know the g of x is on bottom in this situation. And then I need to find the starting and ending point of this region. That just takes figuring out the intersection points. I can use Desmos or any other graphing feature to do that, or you could do it by hand. I'm going to utilize the graphing feature. Notice that the left-handmost point is -3, 0, and the right-handmost point is 2, 5. So in terms of x values, we're going from -3 to a +2 when we're integrating. Let's set up the integration for the area. Now I only need one integration here. Like I said, it goes from -3 to a +2. The f of x is going to be on top. In this case, that's 9 minus x squared. And the g of x is going to be on the bottom. So minus x plus 3. In terms of how we integrate, I like to simplify what's inside of these parentheses before I start integrating. I'll combine like terms when I do that. The x squared component is going to be a -x squared. We're going to have a minus x. We are also going to have a 9 minus 3, which is a +6. That means I want to integrate -x squared minus x plus 6 with respect to x from -3 to 2. Now it's time to apply the fundamental theorem of calculus. Find any antiderivative, -1/3 x to the third minus 1/2 x squared plus 6x will be one antiderivative. I want to put that x squared being multiplied instead of divided. We are going to start at -3 and end at +2. Let's plug in both of those values. I'm going to plug in the top one first. So I'm going to plug in the 2. Everywhere I see an x. and then subtract. I'm going to then plug in the -3 everywhere I see an x. All right. Now let's plug things into our calculator. That first quantity is going to be -1/3 times 2 to the third minus 1/2 times 2 squared plus 6 times 2. That gives me as 22/3. Sometimes that's easier to deal with improper fractions than mixed numbers. When you plug in the right-hand values, what are the values in the right-hand brackets, what I ended up with is a -13.5. If I wanted to write that as a fraction, that would be -27/2. -13.5 is okay as well. When you combine those, depending on what way the answer wants to be, if you want the answer as an improper fraction, it would be 125/6, which is 20 5/6. As a mixed number. And that is about 20.83. So whichever way you write it, we have our answer there. In Moodle, I believe it asks you to round to 2 decimal places. So there you go. That is how we deal with area bounded by curves. We graph it, see which one's on top. The bounds are determined by where they cross, by where f of x and g of x cross in this case. And then we're moving on. I would like you to push pause on the video and try this one. In this case, we have 3 curves, and I want you to try to find the area bounded by those 3 curves. Again, each one needs to be on the perimeter. Push pause, try the video, and then in the next video, I will try to go over it.